We'll now continue our discussion on section 4.1, talking about polynomial equations and their graphs. Let's review for a second the definition of a polynomial equation. Remember that a polynomial equation in one variable, say the variable is x, is an equation that can be written in the form a sub n x to the n plus a sub n minus 1 x to the n minus 1, and so forth. What we want to note in this definition is that a sub n is called the leading coefficient. So this is the number that sits in front of the highest power of x. That is called our leading coefficient. And we also want to note that the degree of the polynomial equation is the highest exponent, so the n value. Those two terms, the leading coefficient and the highest power of x, can give us indications about the behavior of the graph. If your leading coefficient is positive, okay, so remember that this a sub n is your leading coefficient, that number that sits in front of the highest power of x. If that is positive and your n is even, remember that the n is going to be your highest power, then we know that our graph approaches infinity on both sides. So in other words, the graph goes up on both sides. If the highest power is odd, then what we know is that on the left-hand side, the graph goes down, and on the right-hand side, the graph goes up. Now, consider what happens if your leading coefficient becomes negative. We know that putting a negative onto a function has the effect of flipping that function over the x-axis, of reflecting it over the x-axis. So if that leading coefficient is negative, then instead of, here's the positive, instead of both of those edges going up, if we have a negative coefficient, both of them go down. Similarly, if it's positive and the left-hand side goes down, then when it becomes negative, that left-hand side goes up. And flipping back once more, if the a sub n is positive, the right-hand side goes up. You put a negative on it, that right-hand side is going to go down. So we want to keep that in mind, that end behavior of the graph, and the fact that it's determined by the leading coefficient and also by whether the highest power is even or odd. So let's look at an example. So here we have three examples, and we want to sketch the graphs of the polynomial functions. We want to note the x-intercepts, the y-intercept, and the behavior on the ends. And this expression right here where we say x is going to positive and negative infinity means what's happening on the edges of the graph, on the end behavior. Okay, so let's start with part A. Our part A function is f of x is equal to negative x times 2x plus 1 times x minus 2. All right, so the first thing that we're asked to find are the x-intercepts. And we want to keep in mind here that when we're talking about the x-intercepts, they could ask us to find the zeros or find the roots. Those are different ways to ask the same question. All right, so remember that when we are finding the roots or the x-intercepts, that our approach is to set our function equal to 0. So let's do that. Let's take our function. For our x-intercepts, we're going to set the y equal to 0. So we're going to have 0 is equal to 2x plus, or negative x times 2x plus 1 times x minus 2. And then we'll set each part of that equal to 0. So the negative x, setting it equal to 0. The 2x plus 1, setting it equal to 0. The x minus 2, setting it equal to 0. The only way that negative x can equal 0 is if x is equal to 0. On this one, we're going to solve for x. So we're going to 2x plus 1 equals 0. We're going to subtract 1 from both sides, which gives me 2x is equal to negative 1. Then we'll divide both sides by 2. And so x is equal to negative 1/2. And then for our third one, x minus 2 is equal to 0. We'll add 2 to both sides, giving me x is equal to 2. So for our x-intercepts, we have x is equal to 0, x is equal to negative 1/2, x is equal to 2, and remember that on all of these, the y value is equal to 0. We are also asked to find the y-intercept. Now, if you notice, we actually already have the y-intercept, but we'll just walk through it one more time. The y-intercept is found by plugging a 0 in for the x. So we're going to say y for the f of x is equal to negative 0, 2 times 0 plus 1, 0 minus 2. Now, it doesn't really matter what happens in that part or in this part, because if we're multiplying by 0, the entire thing is going to 0 out. So that y-intercept is going to have a y value of 0, and we know that when we're talking about a y-intercept that the x is automatically 0, and as I said in the beginning, we actually already had that, so we know that that is both the x and the y-intercept. All right, and then the last thing we were asked to do was to discuss the end behavior of the graph. And so in order to do that, we need to know our leading coefficient, and we need to know that highest power of x. And so the best way to do that is to come in here and actually multiply this function out. So I'm going to leave the negative x alone for a minute, and I'm going to FOIL method right here. All right, so first times first, 2x times x is going to be 2x squared. The outside will be 2x times negative 2. That'll be a negative 4x. The inside, 1x, and the last terms will be negative 2. So simplifying there, we have 2x squared minus 3x minus 2. And we still have a negative x to distribute through. So we're going to multiply this negative x times all three of those terms. So that's going to give me negative 2x to the third minus, actually plus, 3x squared plus 2x. So our leading coefficient is a negative, and our highest power of x is 3. So our degree is equal to 3, which is an odd number. All right, so what does that tell us about our graph? Let's go back and check. So we have a negative leading coefficient. So here we are, negative leading coefficient, and our highest power was odd, which means that the graph is going to go up on the left and down on the right. Okay, so up on the left and down on the right. So I am just going to do a real quick sketch here, and we're going to go on the next slide and pick it up and make it a little bit better. But up on the left and down on the right will be our end behavior. Okay, so let's take a look at this in terms of getting a good graph for this function. So I'm going to first plot my intercepts. So I have the point 0, 0, which is here. I have the point 2, 0, which is here. And I have the point -1/2, 0, which is here. I know that the graph starts as it points up, and I know that it comes down. And I also know that if it's an x cubed function, it has that sort of S look to it, that curve that is characteristic of a cube function. And so that should be enough for me, making sure I go through these points to sketch out that graph. All right, so let's move on to part B. The function for part B was g of x is equal to x squared plus 2x minus 3. And so we'll begin with our x-intercepts. Remember that for the x-intercepts, we're going to set the y part, which is the g of x, equal to 0, which leaves us a quadratic equation. We know that for a quadratic, our best bet is to try to factor it if possible. If not, we'll use the quadratic formula. So first two terms have to make an x squared. That has to be an x and an x. The last two terms have to make positive 3, so it's going to have to be 3 and 1. And I have a mistake right there. Let me fix that real quick or we're going to have problems. I copied it down wrong. That should be a minus. All right, so let's see if that works. Now I'm going to check just to be sure. X times x is x squared. My middle terms, the outside would be -x. The inside would be 3x. That does combine to give me a positive 2x. And then the last terms would be -3. So I think I'm good there. All right, we then take each of those and set them equal to 0 and solve. So on this one, we're going to subtract 3. X minus 3 is equal to 0, so x is equal to -3. X plus 1 is equal to 0. We'll add 1 to both sides. X is equal to 1. And so our x-intercepts, we have the point -3, 0, and the point 1, 0. All right, for the y-intercepts, we're going to set the x equal to 0. So we'll have y is equal to 0 squared plus 2 times 0 minus 3. So y is equal to -3. So our y-intercept is 0, -3. Now we need to look at our end behavior. So again, we're going to note that our leading coefficient is a 1, and it is positive. We're going to note that our highest power is 2, and it is even. And so let's go back and look real quick. A positive leading coefficient, an even highest power gives me a parabola that opens up on both edges. All right, so here we go. So we see that the end behavior, we have that going up in both directions. We can mark off our x-intercepts. Our y-intercept, remember, was the point 0, -3, so there's the y-intercept. And knowing that it increases on both sides, that it points up on both sides, and knowing that if my equation is a squared, it's going to make a parabola, gives me enough information to sketch that graph. All right, our third one, the last one in this example, the function was h of x is equal to x to the 4th minus 1. So again, let's begin with our x-intercepts. So we're going to set the y equal to 0, and we're going to solve. And so x to the fourth minus 1, let's see if we can factor this. What times what makes x to the fourth? That would have to be x squared and x squared. And the minus 1 would have to be a minus 1 and a plus 1. And so it is like a difference of two squares. And you can see that your middle terms will fall out as you go to check. You'd have x to the fourth. You would have positive x squared, negative x squared. Those two would cancel, and a minus 1. Now, this first part we'll factor one more time. It's still a difference of two squares. So we have x and x. We have 1 and 1, plus and minus. All right, so in terms of our solutions, we'll set each of them equal to 0. X plus 1 equals 0. X minus 1 equals 0. X squared plus 1 equals 0. Solving the first one, we get negative 1. Solving the second one, we get positive 1. And look at what happens on this third one. When I subtract the 1, I get x squared is equal to negative 1. And there's no way for me to square a number, a real number, and get a negative. Remember, you square a number, it's always positive. So this one doesn't really produce anything. All right, so our x-intercepts, we have negative 1, 0, and positive 1, 0. All right, let's look at our y-intercepts. Remember, for the y-intercept, you are going to set the x equal to 0. So if you take your function and plug a 0 in for the x, you're going to have y is equal to 0 to the fourth minus 1. Y is equal to negative 1. And the x would be 0. So a y-intercept of 0, negative 1. And then let's think about end behavior. Again, our leading coefficient is a 1, positive. And our degree is even. So we know that, I'm going to flip back one more time, if your leading coefficient is positive and your n is even, you know that both ends are going to point up on your graph. Now, I also know that this graph has the shape of a parabola, but it is a little flatter on the bottom. So wherever that parabola is, and I guess I could just go ahead here. All right, so we have an x-intercept at negative 1, 0. We have an x-intercept at 1, 0. We have a y-intercept at 0, negative 1. And I know that it has the parabola shape to it, both ends pointing up. But it's going to flatten out a little bit across the bottom. All right, and so I'm going to show you the textbook graph just so you can see it a little bit better. That's the same graph that I just drew. So we want to be able to do that for a polynomial equation. We want to be able to find the x-intercepts, the y-intercepts, and then talk about that end behavior so that we can roughly sketch out a graph for our function.